is a lesson on calculating equilibrium concentrations and is an equilibrium occurring. The first thing is, are you in equilibrium? This will tell you which way the equilibrium will shift or not. So you do a test case, which is Q. Q is set up exactly the same way, concentration of products over the concentration of reactants. Products over reactants, and this is a test case, and it may or may not be equal to the value of K. If Q does equal K, then yes, you are in equilibrium. If Q is greater than K, you have too big a number on top, which means too many products. Which means you need less products and more reactants. If Q is less than K, then the reverse is true. You have too many reactants, which means you need fewer reactants and more products. Example, let's go back to our unimaginative hydrogen plus iodine solutions, let's call it this time. Equilibrium with 2HI. And you're given that the concentration of H2 at this certain temperature is equal to the concentration of I2 at this temperature, which is equal to 1 molar, and the concentration of the hydrogen iodine is equal to 2 molar. So you plug it into the equilibrium expression formula, which is HI squared over concentration of H2 times concentration of I2, and you should always write this down, even if you're plugging in, helps out, explains to people what's going on. So you have HI squared, so 2 squared is 4, 1 times 1 is 1, so that's 4, which is greater than the value of K, which I did not give you. K is equal to 0.7, so you are not in equilibrium. If it was 4, then you'd be in equilibrium. In fact, you got way too many products, so it will shift and you'll have less products and more reactants when you're done and get to equilibrium. So that's how you can tell if it is in equilibrium or not. Back to our thing, but we're going to use a gas pressure situation here. And now we're going to concentrate what the partial pressure of one of these chemicals, and we're going to do iodine. So the question will be, given that Kp is equal to 0.7, at equilibrium, the equilibrium pressure of the hydrogen is equal to 3.0 atmospheres, and the equilibrium pressure of the HI is 0.5 atmospheres. What is the partial pressure of the iodine? Question mark. Don't know it. Set it up. Mass action expression. HI squared H2 I2. Plug in the values that you know. This is K, P. So that's Kp is 0.7. The pressure of the HI is 0.5 squared. The pressure of the hydrogen is 3. And the pressure of the iodine is unknown. Solve for piece of I2. Pi2 equals 0.5 squared divided by 3 divided by 0.7. If you're multiplying like that, you can just trade partners. Niftiest math trick you ever found. And so the pressure is found out to be 0.12 atmospheres. So if you know all the variables except for one, you can calculate what that missing variable is. If it was HI, then you'd have to do something like square roots. It's possible. It's not bad. Now, we're going to have to use our ICE table to do the other special case. And this is the last of the easy things we're going to be doing. Our old friend, H2 plus I2 equal 2HI. K is equal to 0.7 in this case. And we're going to use our ICE table because our initial concentrations of H2 and I2 are the same, and they are equal to 0.5 moles per liter. And that is all the information you have. So plug in these for the moles per liter. Assume a 1 liter concentration. This equation here is given is a mole ratio thing, not molar. So you might have to worry about making sure that you are in moles and not other units. So this works if it's in moles. If it's a different size container, if it's 2 or something like that, you'd have to divide by 2. The proportions do not always work out to be right, so you have to make sure it's in moles. So the ICE table, our initial concentrations of H2 and I2, initial moles of H2 and I2, 0.5, 0.5, and originally it's 0 here. You don't have to do the Q because these are all the same number, or you can't get a negative, so you got to add to this. How much are you going to add to this? Well, plus some number you don't know, 2x. It's 2x because it's a 2 there. That means the ratio, mole ratio is here and here is 2 to 1, so it's not going to be 2x, it's going to be minus x and minus x. 0.5 minus x, 0.5 minus x, and you add those two together, and you get 2x. These are the expressions you plug into your your equilibrium expression. HI squared, H2, I2. So it's 0.7 equals 2x squared over 0.5 minus x times 0.5 minus x. 0.5 minus x times 0.5 minus x is 0.5 minus x squared. And this is essential for this shortcut method, for the simple way of doing things. Both of these have to be squared. That way you can take the square root of both sides, neatly eliminating all the exponents. So the square root of 0.7 is 0.837 equals 2x, 0.5 minus x. The square roots and the squaring cancels. And now you cross multiply and solve for x. Remember I said this is easy? Wait until you see the next lesson. So half of 0.5 of that is 0.418 minus 0.837x equals 2x. Add that to both sides. 0.418 equals 2.837x. Divide by 2.837, and we get an x value of 0.147. This is not the answer. That's the amount of change. Now we need to go back up here and find out what the equilibrium concentrations are. So 2 times 0.147 is 0.294 moles per liter. 0.5 minus 0.147 is 0.353 moles per liter and 0.353 moles per liter. So the equilibrium concentrations are this. Now, if it wasn't zero and you didn't know which way to shift, say we had H2 plus I2 equilibrium 2HI, we start off with 0.5, 0.5, and 1. Are you going to add or subtract? Well, you got to go back to the Q value and find out which way you're going to shift. Q is equal to 1 over 0.5 squared, which is that, which equals 4. 4 is too big. That's greater than 0.7. So that means you are, looking up here, got too many products. So you're going to subtract x, not just x, but 2x because of the coefficient. Wherever the coefficient is here, you're going to put the coefficient down there. Same thing. Here you're going to add x and add x. 0.5 plus x, 0.5 plus x, and 1 minus 2x. Plug it into the K, the equilibrium expression, which is here. I'm going to write it down again. 0.7 equals 1 minus 2x squared, 0.5 plus x squared, square root both sides, 0.837, 1 minus 2x, 0.5 plus x, cross multiply, 0.418 plus 0.837x equals 1 minus 2x. Add 2x both sides. 2.837x equals, subtract that, 0.582 and divide by 2.837. X equals 0.205. That's not the answer. You got to plug it back in up here. This would make this 0.705 moles per liter for both of those. And double that is 410. So 1 minus 0.410 is 0.590 moles per liter. So that concludes this lesson on calculating equilibrium concentrations the easy way.